In this video, I quickly would like to show you how we could use the revolve command to create a table leg. So here I have my tabletop 29 inches above the ground with the sketch below. And I would like to know from the top actually where my table legs will be joined to the tabletop. So the tabletop has a squarish base. The wood turned, so wood lathed table leg actually will be roundish. So we need to build a transition from round to squarish. And there are multiple ways now how, for example, we could do this. Ideally, I would like to start from the beginning and plan out maybe how big is the base where maybe my leg actually attaches to the table. So I go to my sketch. I am in top view, but let me rotate to there. And then I will draw myself somewhere here a line and a line. Okay. And I will draw a diagonal line. So this line, for example, I say is 2 inches. And the dimension is D78. So D78. Okay. And I have this diagonal line. You might ask yourself, what's the point for it? So these 3 lines I set to construction. You see they're also perpendicular to those lines, and the endpoints are coincident. So that means when I adjust actually the tabletop, the piece follows it. And the diagonal has a midpoint, and at the midpoint of that diagonal I can actually draw a point. So this point I just placed somewhere, and then I say midpoint, this point to the midpoint of this line. Perfect. So when I adjust this one to 4, you see the rectangle grows, the diagonal grows, the midpoint moves, and that moves actually the center point. Or not center point, this point we added. Okay, so where's this point coming in very handy? I would like to have right under this point a ray down to the ground plane. So I know actually where my leg axis will be, because I would like to also create under this point a line, and then along that line or a ray actually a construction plane. So I will create a new plane on the ground, and for example I call this one later leg reference, and then project just the point down, and that's all I need. So for example leg center floor point. So now you see I have 2 points, and again when I change actually the dimension for this table, also the lower point moves because it's constantly projected down. And when we go to construct, there is a command axis through 2 points, number 1, number 2. And now this axis is actually exactly my leg axis. And I can use that axis to create a plane at an angle. There. This is, for example, now my leg plane. And again, if, for example, this is moved 50, you see that construction plane moves with it. And the sketch we will glue onto that construction plane will also move with it. Okay, so this can hide actually, oh hold on, no, actually we keep this for the moment, and then we create a new sketch on here. And I would like to 3D include actually the sketch. I could also use project, and then I hide this one. And now you see there we have this magenta line, and that basically tells me somewhat the where the center is. One thing to also keep in mind, you see there is this axis and there's a red dot, and the red dot is at the ground plane of our world. Now if I go into the sketch for my leg, so edit sketch, you will see that the red line moved up. So I do not in this case want to start drawing from my world center, because this is actually my world ground center point. Okay, so knowing that, from this point I can draw a line out and a line up. This is, for example, my bottom part. I can add some dimensions there and there. And actually, I would like to create an angle. I can't, because I have, for example, this 90-degree perpendicular constraint. So I delete that one. I delete this. And then I go back, U and U, and 110. And you see it moves this one line over. Maybe 4 inches. This maybe should be 2 inches. And you see this line is vertical. This blue line is perpendicular to this line. And then this line is 110 to this line. I hope you start at one point realizing kind of like the logic and rules and how we can use these constraints to make sure that certain lines are horizontal or vertical, so we don't have to always constantly measure them or take care of that they don't rotate by accident. Okay, so this is actually a little bit too big, 1 inch and 100. Okay, so I would like actually now maybe on top, let's hide all this other stuff I don't really need, and I will put down a line up here and a line down. So the distance between this line and this line has to be 29 inches. And actually, if we want to be correct, we use this dimension, so D1, which is 29. So this point to this point, D1 equal 29. Perfect. We can also say here and there we have some dimensions. And now we have the ability to maybe place some curves there. And then have a very simple shape. And you see, like, based on where I move these points, I can get different proportions. Right click, insert fit point, and then click on a line, escape, and then click and move that point. Adds a point, click a point, delete, removes that point. That's kind of like the way how we can work with the spline. And you see the spline creates an organic smooth curve that always runs through these points. It's important when you draw the spline that you start and end on the lines, so you get this yellow filled area. So let's see what else we could do with the dimensioning. Just to give you some ideas, we could decide how far, for example, these points are away from each other. Or we could also say how far they are this way. So the distance between them. So instead of adjusting it by hand, I can simply write this stuff in. For the moment, I just leave it this way. I will come back to it at a later point. And then I can create a revolve for this one along maybe this line, 360, important new body. Okay, and let's take a look at our tabletop. So there already we see problem number 1, the top is way too big, and secondly, it is also kind of, how could I say that, it's roundish, but it has to have a flat transition. So how could I maybe figure out to align actually these two parts? So I will just create myself a new sketch, and I click actually on the top of that cylinder. So you see I can create a construction plane and make a sketch on it. I can also click on a flat geometry and make a sketch on it. The advantage of this is actually when we move the leg, the sketch runs with it. And I just want to see my tabletop right now, and you see kind of like what rectangle I have to create on it there. So there are multiple ways maybe how we could try to address it. So this is a circle, and a perfect circle always has a center point. So I could actually go ahead and say, let's somewhere draw a rectangle. I on purpose drew this cricket. So you see again how I adjust everything. And then let's say 2 inches. What's this dimension? That is D93. So D93. And actually this is not really maybe the way how I want to do it. What is this actually? This is D79. D78. Okay, so let's go back to the sketch. So we set D78, and we do the same here as well, D78. So for example, this rectangle will always have the same size as, for example, the rectangle of our table, which we added. And now the rectangle has no center point, in contrast to, for example, the circle. So how do we find that center point? Very easy. Geometry 101. We just draw a line edge to edge, and then we make this line horizontal. And whoa, oh, went to there. Well, this is garbage. No problem. We say midpoint, this endpoint of this line to this line. So you see now this line is midpoint centered to this line. And we can, for example, create another point there. And then we say this point, midpoint to this line. Okay, now if I click on this point, you see everything moves around. And now I could say coincident this midpoint to the center of my circle. So that actually should do it. Let's see if we can actually move this around. No, we cannot. So perfect. Good. You see actually that this outside cylinder is really massive. So let's actually, before we do anything, adjust the dimensions a little bit. So 1.5, and it gets closer. You see, I keep it a little bit bigger. This actually will ensure that I have an area where those four circle shapes or areas are joined and have a small transitional bridge between them. And this can really be very, very minimal. So this is good, because what we will do now is go to create, extrude, select this one, and then extrude it down. And you see, if we then even go further, it starts trimming it this way. And that is the reason why in my side profile, this is actually very concave. So when I cut down, I get this nice profile. So height dimension, because that increases the screen refresh. Okay, let's go back to the tabletop and take a look at what we have. So this is, for example, actually, let's call this correctly, lag top square, show dimensions. So again, maybe we can play with the proportions a little bit. No, I can actually move this one in a little bit, but then that moves this in a little bit. So maybe 1 inch, maybe a little bit more there. Let's move it this way a little bit. Okay, so what else can we do now? So let's try one thing out. What happens if actually we adjust this one to 40? We get this. So what happened? So these points, those blind points, are constrained, but there's nothing that tells how far this point should be to this point. So we moved the sketch, but we didn't tell these points to maintain a distance to update, so they stayed where they are. Think about them, they're very lazy. So what we call actually a sketch is either a fully constrained sketch or a not fully constrained sketch. And currently this sketch is partially constrained, because meaning this point has some information, but it's ultimately not really complete. So I can select these 2 points and maybe say here, this distance, sometimes the command is a little bit finicky. So you there, click OK. I can drag this one out, and so I don't have a definition between this one and this one. I could also say you and you, that distance works as well. Okay, stop sketch. So let's see what happens if we adjust this value now one more time, 50. And zip, you see everything moves with it. Perfect. So that's the reason why the dimensioning is useful, and in certain areas also really required. So what is basically left is to create clones of our legs via the mirror command. So mirror bodies this leg along this plane. Okay, then one more time, mirror this one and this one along this plane. Okay, and there we are. So if we now say this should be 40, the legs will be further apart along one axis or the other axis. And I think at this point now you start realizing why I said you can do this type of work. So you can create that geometry in AutoCAD, obviously. There are also a lot of similar tools, but if the process is really that comfortably easy and the same, it is not. And this actually shows where, for example, Fusion, for what we try to do here, is simply a more contemporary or appropriate tool for the way how you want to work as a designer. And that's pretty much everything for how to make those table legs.